All right, welcome back. So today we are going to be going over how to solve quadratic equations by a process we call completing the square. Now, a lot of times you are going to get quadratic equations that we can solve by factoring, right? We can use the grouping method or any other method that you enjoy for factoring. Sometimes we're going to get equations that we can't factor, but we still need to get the values of x, right? We still need to solve these quadratic equations. And completing the square is a process that we can do to find the values of our variables, to solve these quadratic equations. It can get a little bit confusing. Bear with me. I'm going to try and break it down for you. But once you start to get the hang of it, you're going to notice that you might really enjoy it. I know personally I really enjoy it. But it can be a little bit daunting in the beginning, so just bear with me here. So again, today we're going to be working on completing the square to solve quadratic equations. So here is pretty much the general concept of how we complete the square. So please pause the video, copy down the notes, and then we're going to go over it together and then go through a lot of examples. So with completing the square, in words, it says to complete the square for an expression of the form a squared plus bx, follow these steps. So it says step 1, we want to take 1/2 of b, the coefficient of x. Remember, b is this value right here, right? 1/2 of b is going to be that value right here. So we're going to take half of that. Then we're going to square that result from step 1. So if we took half of b, right, it would be b over 2. We're now going to square that. So it's going to be b over 2 squared. And then we're going to add that to x squared plus bx. So it would result in just like we have down below, where we have x squared plus bx now plus b squared over 2. And there's this trick that we can do, and we can rewrite it into this finalized form, x plus b squared over 2, b over 2 squared. So let's show what that means, though, within an example. So in this example, it says complete the square for the expression, then factor the trinomial. So we want to take our b value, which is 10, and we're going to take half of that. So over on the side, I'm going to put b over 2, and we write that as now 10 over 2, which is 5. Now we're going to square that. So now it's going to be 5 squared equals 25. So we're going to rewrite this now as x squared plus 10x, now plus 25. And now you might notice that this is a perfect square trinomial, where we can factor it to x plus 5 times x plus 5, or we can write it as x plus 5 squared. Notice that 5, let me highlight real quick for you, that this 5 right here is half of b squared. Little kidney shape there for you. So what we did is we took half of b, squared it to get 25, right? But the half of b before we square it appears in our final answer. It's going to be x plus 5 squared, right? So if we can understand this trick, then we can skip a few steps, right? But we're not always going to see just a binomial here, right? We have x squared plus 10x. We're going to see a quadratic or a trinomial. So we're going to see something that looks like this. We have solve x squared minus 16x plus 15 is going to be equal to 0. Now we need to change this quadratic into a binomial on the left-hand side, or on one hand side, I should say. So in order to do that, we're going to have to subtract 15 on both sides. So now we have x squared minus 16x is equal to negative 15. So what we're going to do is we are going to take half of b, just like we did before. We're going to take half of b, just like we did before, and we're going to square it. So half of b, so b over 2, translates into negative 16 over 2, which is negative 8. We're going to do negative 8 squared, which is 64. So what we need to do now is add 64 to both sides. So it's going to turn into x squared minus 16x. Now, plus 64 is equal, come on, that's not what I chose. No, that was too much. Plus 64 is equal to negative 15 plus 64. Because remember, law of equality, what we do to one side of the equation, we do to the other side. We needed to add 64 on the left-hand side to complete the square, so we need to add 64 to the right-hand side to keep it balanced. So now we can simplify a little bit. X squared minus 16x plus 64 turns into x plus b over 2, right? Remember back to our notes here, right? It results into x plus b over 2 and that value squared. So b over 2 was negative 8. So it's going to be x minus 8 squared is now going to be equal to 15 plus 64, which is 49. And we simplify that down. And now we can solve, right? We have x minus 8 squared equals 49. So we can take the square root of both sides. That cancels out. And we're left with x minus 8 is equal to plus or minus 7. And now to solve for x, we add 8 to both sides. So we're going to have two instances here. We're going to have that x is equal to 8 plus or minus 7. Since we can simplify this, we're going to have our two answers. We're going to have x is equal to 8 plus 7, which is 15, and x is equal to 8 minus 7, which is 1. You might also see it abbreviated like this in a bracket, 115. And that's our answer. That's how we complete the square. Cool, nice job, right? But it's not always going to be as simple as this setup, right? We might have something that looks like this. We said solve 2x squared plus 20x minus 8 is equal to 0 by completing the square. So let's go through how we would do this. So the first thing we're going to need to do is I'm just going to rewrite it plus 20x minus 8 is equal to 0. We want to have a binomial term with our x squared and our linear, our bx. So we're going to have to add 8 to both sides. When we do that, we get 2x squared plus 20x is equal to 8. Now what's different about this setup and the previous setup is that we have a coefficient in our quadratic term. We have 2x squared. So for completing the square purposes, we want that coefficient, or we need that coefficient to be 1. We need to divide everything by 2. We're lucky right now that it turns out to be friendly numbers. Sometimes you're going to have fractions, and that's okay. You're just going to have to keep going with the process. Trust the process here, folks. So we're going to cross that out. So we get x squared now plus 10x is equal to 4. And now we're going to go through completing the square. We're going to take half of b, which is 10. So it's going to be, again, remember, it's b over 2 translates into 10 over 2, which is 5. We're going to square that. So now we're going to add 25 to both sides. So we get x squared plus 10x plus 25 is equal to 4. Nope, I want blue, thank you. Plus 25. So now we continue with our process here. We have a perfect square over on the left-hand side. This factors into x plus b over 2, which is 5 squared, is now equal to 4 plus 25, which is 29. Notice 29 is not a perfect square, so we're going to have a radical here. When we take the square root of both sides, these cancel, and we're left with x plus 5 is equal to the square root of 29. Some teachers are going to say, hey, leave it as a radical. Some teachers are going to say put it into a decimal. Personally, I like to leave it as radicals because those are exact answers. And now we need to solve for x, so we need to subtract 5 on both sides. Oop, forgot my plus minus there. Caught me slipping. So now we get that x is equal to negative 5 plus or minus the square root of 29. We can't simplify 29 at all. It's just going to say as radical 29. So for my purposes, I am comfortable with this answer. You may need to write it as x is equal to negative 5 plus the square root of 29, and x is equal to negative 5 minus the square root of 29. Either or, 6 to 1, half a dozen the other. It all depends on the way your teacher wants it done. All right, folks, that's how we complete the square. Again, just want to go through a quick review of it. When we have a quadratic equation, we want to move the c value over to the opposite side. That way we have a binomial with our quadratic and linear term, or the x squared and bx term. We need a to be 1. We need that ax squared to be 1, right? In this example, it was 2. In this example, we had 2x squared. We simply needed it to be 1x squared. In order to do that, we divide everything by the coefficient. We were lucky that it turned out to be some nice numbers for us, some friendly numbers. So we resulted x squared plus 10x is equal to 4. We need to we do the process of completing the square here by taking half of b, squaring it, and adding it to both sides of the equation. So now we get x squared plus 10x plus 25, because half of b is 5, 5 squared is 25, is equal to 4 plus 25. We have a perfect square trinomial now, where it results in x plus half of b squared. And then we add the terms on the right-hand side or the opposite side, take the square root to negate the squaring operation, and then we solve for x just like we have been normally. You're doing so well with this. Again, I know it can be a little bit complicated, but if you just keep trying it and trying it and trying it, you're going to master it. Okay, it's going to be a process where you might find it's a little bit easier because it's just a procedure. I, again, personally love it. Some people aren't big fans of it, and that's totally okay. You might get an instance where you will have something that looks like this, maybe. I don't know. You'll get the quantity of x minus 5, I don't know, squared is equal to negative 4. Remember, when we take the square root of both sides, these cancel out. That's great. We get x minus 5 is equal to the square root of negative 4. For our purposes in Algebra 1, we cannot answer this problem. This is going to be a no solution because we can't have a negative sign under the radical. So we would say no solution. Okay. If you are in Algebra 2, you are going to see this as an imaginary number, but for Algebra 1 purposes, it's going to be a no solution. Great job, everyone. So proud of you. Stay safe, and if you have any questions, please feel free to reach out.